What if I told you that time, that steady, relentless ticking you feel every second of every day, isn't what you think it is? What if I told you it's not a straight line, but a river, and you're already traveling on it in ways you can't even imagine? For centuries, we thought time was a constant, a universal clock ticking at the same pace for everyone, everywhere. But then, a young patent clerk named Albert Einstein completely shattered that idea. His theory of relativity revealed something mind-blowing. Time is not absolute. It's flexible. It can be stretched, squeezed, and warped. How? It all comes down to two things: speed and gravity. The faster you move through space, the slower you move through time. And the stronger the gravity you experience, the slower time flows for you. This isn't just a wild theory. It's a proven fact of our universe. Let's look at a real-world example. Astronauts. The brave men and women who live and work on the International Space Station are orbiting Earth at an incredible speed of about 17,500 miles per hour. Because they are moving so fast, time for them ticks just a tiny fraction of a second slower than it does for us down here on the surface. When they return to Earth, they are ever so slightly younger than they would have been if they had stayed home. It's not much, just a few milliseconds, but it's real. They have literally traveled into our future. And it's not just speed. Gravity plays a huge role too. Einstein showed us that massive objects, like planets and stars, create a dip or a curve in the fabric of space. Think of it like placing a heavy bowling ball on a trampoline. The fabric sinks. The closer you are to that massive object, the deeper you are in that gravity well, and the slower time pass. This effect is crucial for technology we use every single day. Your phone's GPS relies on a network of satellites orbiting high above the Earth. These satellites experience weaker gravity than we do on the ground, so their internal clocks actually run faster than ours. If engineers didn't constantly correct for this time difference, your GPS would become inaccurate by several miles within a single day. So the next time you use Google Maps to find the nearest coffee shop, you can thank Einstein's theory of relativity for making sure you want to end up in the next town over. This phenomenon is called time dilation. And here's the most shocking part. You are doing it right now. We are all time travelers. Every step you take, every car ride, every flight you've ever been on has minutely altered your personal flow of time compared to someone standing still. We are all constantly traveling into the future, just at a rate of 1 second per second. The question is, can we speed it up? The answer is a definitive yes. To really leap forward in time, you'd need to approach the speed of light. Imagine you boarded a spaceship that could travel at 99.9% the speed of light. You take a journey for what feels like just 5 years to you. When you return to Earth, you'd find that decades, maybe even centuries, have passed. Everyone you knew would be gone. You would have effectively jumped into the distant future. The world would be completely alien to you. But things get even weirder when we talk about black holes. These are the most extreme objects in the universe, with gravity so intense that not even light can escape. A black hole warps space-time to an unimaginable degree. As you get closer to its edge, the event horizon, time would slow down dramatically for you relative to an outside observer. If someone were watching you from a safe distance, they would see you slow down, appear to freeze, and then fade away over an infinitely long period. But from your perspective, time would continue as normal, as you cross the point of no return. Inside a black hole, the laws of physics, as we know them, break down completely. Some theories even suggest that black holes could be gateways or wormholes to other parts of the universe, or even other universes entirely. So, we know traveling to the future is possible, at least in theory. We do it every day. But what about the ultimate sci-fi dream? Traveling back to the past. This is where things get really complicated and controversial. Traveling backward in time presents a whole host of paradoxes that seem to break the fundamental laws of cause and effect. The most famous of these is the grandfather paradox. What would happen if you went back in time and prevented your grandparents from meeting? If they never met, one of your parents would never have been born, which means you would never have been born. But if you were never born, how could you have gone back in time to stop them in the first place? It's a contradiction that seems to make backward time travel impossible. It's a rule that the universe seems to have to protect itself from logical inconsistencies. However, science loves a good puzzle, and physicists have come up with a few speculative, and I mean asterisk, highly asterisk, speculative ways around this. One idea is the multiverse or many worlds interpretation. In this view, if you went back in time and changed the past, you wouldn't be altering your own timeline. Instead, you would create a new parallel universe. Your original timeline would remain untouched, but you would now exist in a branch in reality where your grandparents never met. You could never return to the universe you came from. Another mind-bending idea involves something called closed time-like curves. These are theoretical pathways in space-time that could, in principle, loop back on themselves, allowing for travel to the past. However, even if these pathways exist, the universe might still have a chronology protection rule in place preventing us from using them to create parallels. Anything you tried to change in the past might have been destined to happen all along, or some cosmic law would prevent you from succeeding. So, can we really travel through time? The answer is a fascinating, complex yes and no. We are all travelers hurtling toward the future, and with enough technology, we could leap ahead by years or centuries. But traveling to the past, that remains the holy grail. A puzzle that might be fundamentally unsolvable. A door that may be permanently locked by the very laws that hold our reality together. Or maybe, just maybe, the key is out there, waiting in the deepest, darkest corners of the cosmos for us to find. The truth is, time is far more mysterious and wonderful than we ever imagined. Thanks so much for exploring the mysteries of time with me today. If you enjoyed this journey through space-time, make sure to hit that like button and subscribe for more deep dives into the biggest questions of the universe. Let me know in the comments, if you could travel in time, would you go to the future or the past? See you in the next one.